my dear students, how are you all? I hope you all are fine and doing good in your lives. So, yes, a very happy new year to all of you. And I wish that your all wishes come true, all your commitments, resolution for this year you all can complete them. And yes, I am back after so long. So today we are going to end the chapter 14 NCERT textbook of your class 7th. All right. So as in the part 1 section, we have already learned that what is electric current, right? We have already learned about the electric current, the what all we have learned. We just revise all that content once again, and then we will start the part 2 of this chapter. So already we have studied electric current, which is the flow of charges, right, through the conductor, right? So we have already learned about insulators and conductors in the part 1 section. We have learned about the components of the electric circuit followed by the electric circuit. So electric circuit, the framework from where the current flows, and also the components of electric circuit, which involves the cell, the battery, the bulb, right? And these are the wires, the button, the switches, right? All makes up the electric circuit, right? And the current as well. All right. After that, we have also learned about the heating effect of current, right? The current which produces heat, right? All right, so all these we have covered from this chapter. So in this part, we are going to learn all the leftover topics of this chapter. Also, we will try to finish the NCERT exercises also. All right, so let's begin. All right. So apart from the electric circuit components that we have studied, include the wires, the switches, the battery, the cell, there is one more component which is electric fuse. Have you ever heard about it? All right, so we will see what is electric fuse is all about. I'm sure you must have seen this type of structure at your homes. So this type of structure is none other than but the electric fuse. And what is electric fuse? Electric fuse is a small device used to protect the electrical circuits from damage due to overcurrent when too much current flows through the circuit. So basically, this fuses are our friends, right? It helps us to prevent the damages in the electrical appliances which may occur due to the overcurrent, right? Now there are two things which can happen if we do not have electric fuse in our circuits or in our devices. So electric fuses actually consist of a short length of thin wire. You can see this is a tin wire. And why this wire is made of tin, because tin has the low melting point, right? So you know what happened whenever the current is overflowed, all right, or overpowered current is being flowed in the circuit. So what happens, first of all, this fuse, what this fuse will do, which has a thin wire of tin, will start burning out or get fuse immediately. Okay, why? Because it helps in safeguarding the electrical appliances from the overflowing of current. That is why it is very important to equip every device with the electrical fuse. All right, so the tin plated copper having a low melting point makes it and helps in breaking the circuit immediately when it is overheated or overpowered. Now, if we are not equipping the devices with the electric fuse, what will happen? So, there are two possibilities. Number one, first, we will learn what is the cause of excessive current flow in wires. So there are two things, two possibilities which makes the current to be overflowed or overheated. First is overloading. So you have seen this picturization which you can see on the screen. A situation where too many electrical appliances which are being connected to a single circuit, it leads to overloading. All right. And also there is a short circuit. There is a situation, students, where short circuit happens. What happens, all these wires are actually made up of two wires inside it. Okay. So inside these wires, inside these insulated plastic covers, right? What is present? Two types of wires are present. Number one is the live wire, and the other one is the neutral wire. Okay. So these two wires actually helps in running the electrical appliances. But what happened? The situation comes when these wires faces wear and tear, or they tone up. Okay, you can see here wear and tear happens. So in these situations, these two wires overlaps with each other, and this results in short circuit. In short circuits, you must have seen the fires, sparks coming out from the electrical devices. So when electricity flows through a part with a very little resistance, usually because two wires touches each other, live wire and the neutral wire. So this can cause too much current to flow, which can be dangerous and may lead to sparks, fires in electrical devices. So these are the two possibilities which lead to overcurrent or overheating of the circuit. All right. All right. So in order to safeguard or to prevent such situations, we need electrical fuse. So this is the one more important component of the circuit. All right. Now, the next topic which we need to cover. Now, before we go on with the next topic, there is a question for you. Imagine you are using an electrical appliance at home and suddenly there is a power surge. Okay, means short circuit happen. The fuse blows and you have to replace it to get the appliance working again. Obviously, you need to change the fuse in order to run that circuit or run that appliance again. But what if you don't have to replace the fuse and could just flip a switch to restore power? That can happen, right? It is very lethargic that you keep on calling the electrician for replacing the electric fuse. So can it be happen if we can have the alternatives, right? So in modern electricity or in modern electrical technology, there is MCBs, miniature circuit breakers. I know you must have seen these boxes and all these type of switches or type of circuit you have seen, right? So all these are termed as MCBs, miniature circuit breakers. So these are the alternative of electric fuse. So nowadays in modern electrical systems, MCBs are being used in place of fuses. And now what they do? MCB works on the magnetic effect of current, right? Yes, we have studied about the heating effect of current. Now this is the second major topic of this chapter which we are going to see through MCBs. That is magnetic effect of current, and get automatically off when the current in a circuit exceeds the safe limit. The electric fuses get fused first and then we have to replace the fuse in order to make the circuit again work, right? But in MCBs, it can automatically turn off and whenever the current exceeds the safe limit. By simply turning them on makes the circuit completes again. Do you know how? How we can make these MCBs turn on, like this. See, there is an picturization demonstration where an electrician or any family members can just switch it on again to run the appliance again. See. All right. So this is the way in which you can simply just switch it on and the circuit will run again. So this is very easy, right? Apart from calling the electrician to come and change the electric fuse, we can automatically turn it on, right? So these are miniature circuit breakers which are known as MCBs. Now the question arises, what is magnetic effect of current? We have studied about the heating effect of current, where when the current flows through the wires, it produces heat, right? So there is one more effect of current which is magnetic effect of current. So let's learn what is it. Now you can see there is a circuit there, right? You can see the wires is there, or you can say it's a coil of wire, right? And there is a device which you can say ammometer, which is used to calculate the current. Okay, so the magnetic effect of current is when an electric current flowing through a wire creates a magnetic field around it. So we have already learned that heating effect of current is what? That the current produces heat. In the same way, when the current produces the magnetic field around the circuit, that is known as magnetic effect of current. Now, you know who came up with this? There was a scientist whose name was, actually he was a physicist, right? Scientist, but from the physics subject. So he is known as the physicist Hans Christian Ørsted. Was the first to discover the electric current produces a magnetic field around a wire. So to produce a strong magnetic field, we can wrap the coils of wire around an iron piece, also known as solenoid. Okay, so as you can see in the picture back, see this one. So there is a iron piece, okay, and then when we keep on coiling this iron piece with the copper wire, right? Okay, we are going to round up the copper wire open, okay, on this piece of iron. So this makes up the solenoid, and then when we connect this with the wires, and the switch, and you can also connect the bulb here. Okay, so all this makes up the circuit, right? So this hole is the solenoid. See, solenoid is an experiment you must or usually do in your school. So there is an iron nail, okay, iron nail is there, and you are suggested or you are asked to keep the iron rod, and then you need to coil the wire on it. And by this iron nail and this iron rod and the copper wire, you make a whole circuit. So this all structure is known as solenoid. Okay. Now, what does this solenoid do actually? So that is why it is written, wrapping the coil of wire around an iron rod. Current passing through the coils of wire magnetizes the rod. Okay. So the current which is being passed through the wire, what it will do? It will magnetize the rod and will produce a powerful magnet which is known as electromagnet. Now that the coiled up magnetic piece is not the simple magnetic piece, simple iron piece, but it is now what? The electromagnet. Okay, as you can see here, this is coiling, and this iron nail is being coiled up. Now when you will connect this with the cell roll battery, it will act as the magnet which is known as electromagnet. The more loops in the coil, the stronger the magnetic field. So sometimes the question is being asked, how can we make electromagnet more strong? So by coiling up or by increasing the loops of the coil, you can make the stronger electromagnet, because it will increase the magnetic field around it and hence makes the magnet more stronger. Electromagnets are used in electric motors, loudspeakers, television sets, doorbells, trains, and many other devices. So in your NCERT, basically the electric bell example is being given, and we are going to study electric bell in detail, which is working on the principle of electromagnet. Okay, so there is one more scientist apart from Hans Christian Ørsted. There was Faraday, electromagnetic induction. He has given something which is working, which works on the inducing of the electromagnetism. Okay, inducing the current. Okay, so the process of creating an electric current by moving a conductor through a magnetic field or by varying the magnetic field around it. He has worked on it. The majority of the electricity supplied to homes is generated using electromagnetic induction. Okay, so we are going to study applications of electromagnet, and one of the major, yes, so in this way you can also make your solenoid. Okay, you just need a piece of iron and copper wire, and you just can coiled up the piece of iron, and tada, that is your solenoid, which you can connect it with the whole circuit, and it will produces what? Magnetic field. And what you need to do to make it more powerful, you just need to increase your coiling. Okay, so now this piece of iron is acting as electromagnet as well. Okay, when you just join this electromagnet with certain wires, then it will become the solenoid. Okay, all right. So next we are going to learn the one of the major application of electromagnet, which is also present in your NCERT, that is electric bell. Okay, so first of all we need to learn about the structure of electric bell. So for that you need to see this depiction or demonstration that how does electric bell works. Okay, so first of all I will tell you that this U-shaped magnet is the electromagnet which is present inside the electric bell. Okay, yes, so this is the U-shaped electromagnet, and this is a cell. Okay, and this is the switch. Now this is being coiled up, okay, with the wire, and now there is a piece of iron here which is on the lower end. It is connected by the spring, you know, this is the spring, this. Okay, and then the upper end is being connected with the hammer, okay, which is going to strike with this disc, okay, this metal disc. Okay, so I will tell you what will happen as you switch this on. This will start, the spring will just pop that hammer up, and this hammer will keep on striking this metal disc, right? And as you can also see the depiction, I will show you this video. First you will see. All right, can you see that? As the switch turn on, a magnetic field is being produced, and this is keep on going up, and hammer is being striking up again and again. And why it is coming back, you know, because the spring is popping up, and again it is going up and down. Okay, so in this way the electric bell work on the principle of electromagnet. Electromagnet is going to produce a magnetic field, and by that this this hammer is being attracted by this metal disc, and it will keep on ringing the bell. Okay, so for this we are also there is a question which is being asked in the NCERT exercise, that what is the structure of electric bell, its working and functions. So you can see, you can write the answers, or you can take the help from this notes. So first it can ask what is electromagnet. So how does electromagnet is working inside the electric bell. So this electromagnet is in U-shaped. Okay, also you already know that is solenoid which is being wrapped around a metal piece that becomes magnetic when current passes through it. Then you have a battery or power source, because without the source you cannot switch it on, right? So it provides electrical energy to the circuit. And then you have the contact points. These are the points that connect or break the circuit, controlling the flow of current, right? The hammer one, the magnetic piece, this iron rod, the upper part is being connected with the hammer, which is keep on striking the metallic disc, and the lower one is being connected with the spring, right? So these are the two contact points. And then the hammer, a small metal piece that hits the bell to make a sound. And then this is the structure of the electric bell. If they asked to make a diagram, you can make it like this. Okay, it's an easy one. And then you have to also they also can ask you for the working of the electric bell. So first of all you need to tell them how the current will flow. Okay, obviously when you press the button, it completes the electric circuit, allowing the current to flow the battery to the electromagnet, right? And then obviously when the current is being flowed, then the magnetic field is being produced. That is why it is an electromagnet, right? So as the current passes through the wire of the electromagnet, it creates a magnetic field, turning the metal piece into a magnet, right? And then that iron rod is keeping attracted towards the metal disc, right? The electromagnet pulls the hammer towards it, causing it to hit the bell and make a sound. And then the circuit break as well. When the hammer hits, it breaks the contact point, stopping the current from flowing the electromagnet. And then it gets deactivated Without the current, the electromagnet loses its magnetism and the spring pushes the hammer back to its original position. Okay, that means the switch that the current being its current flow is stopped, right? So in this way, the working of the electric bell works, all right, or function. So this was all your whole chapter in which we have studied about electric currents and its different effects, right? Number one, the heating effect, and the second one is magnetic effect. And apart from it, we also have learned about the electromagnet and its application. The most major one, this is electric bell. Okay. Now I will also discuss some NCERT exercise solutions like this. Fill in the blanks. So the answer is being already written. You can take the help from this notes, right? So dash is the flow of electric charge. So it's like electric current. The unit of electric current is ampere. Okay, A. And then the electric current produces the magnetic field around a conductor. The magnetic field produced by a current carrying conductor can be detected using a compass, you know, because whenever you put the compass in front of the electromagnet, it's always deflect toward north to south direction. So it shows that the electromagnet have the this magnetic field around it. Okay, so it happens. You can also check it once when you make the solenoid. Also, you can check, like, if you have an iron piece of rod, for suppose it's an iron piece of rod and you coiled up with the copper wire. Okay, so it will automatically start producing what? Magnetic field around it. If you want to prove that there is a magnetic field around this electromagnet, so how you can prove it? By keeping the compass in front of it, and then you will see the compass always start this because you already know that there is a magnetic needle inside the compass, and that needle is going to deflect, okay, to north and south position. So this detect or this proves that this electromagnet is producing the magnetic field around it. Okay, so you can easily detect. The working of an electric bell is based on magnetic effect of current. We have already learned that. Now there are some questions of true or false. An electric current can produce a magnetic field. Absolutely true. A solenoid is a long coil of wire wound in the shape of circle. No, a solenoid is a long coil of wire wound in the shape of helix, you know, as DNA. It is not in the circle shape. It's a helical structure like this, you know. This is known as helical structure. An electromagnet is made by passing electric current through a wire around a piece of iron. That's true. A current carrying conductor does not produce any magnetic field. False. It do produces, right? A current carrying conductor does produce a magnetic field. If it is written insulator, which does not carry the current in it, then it will not produces any magnetic field around it. Okay. Very short question. So what is an electric circuit? So you already know that electric circuit is a kind of framework in which the current flows, right? An electric circuit is a closed loop through which electric current flows from the power source like a battery to the various components like bulbs or fans and back to the source. You already know it. If you don't know it, please go and revise part 1 first, okay? I will going to attach the link in the description box. What do you mean by electric current? Electric current is the flow of electric charge or electrons through the conductor like a wire. What is an electromagnet? An electromagnet is a magnet created by passing the electric current through a coil of wire wound around an iron core. Name the device that is used to detect the magnetic field. You already know that is a compass. If you need to prove that this electromagnet is carrying the magnetic field around it, so you can detect it with by presenting the compass in front of it. Okay, and then the short answer questions. Why does current carrying conductor produce a magnetic field? Because you know it creates a magnetic field around it. This happens due to the motion of electric charges. You already know that heating effect, right? So this only producing the magnetic field, right, through the wire, which produces a circular magnetic field. What is the role of a fuse then? You already know that it safeguards the electrical appliances from getting short circuit and from overloading, right? A fuse is a safety device that protects a circuit from excess current. If the current exceeds a safer limit, the fuse melts and breaks the circuits, preventing the damage to the electrical components. Apart from it, you already know that despite of fuse, we can use MCBs, right? Miniature circuit breakers. Okay, because in MCBs you're not going to displace or make the fuse keep on replacing, right? In MCBs it will automatically switch off, right? And then you can manually switch it on, right, to make the circuit complete, right? That is why MCBs are being used majorly. Now, how can we increase the strength of electromagnet? By obviously you just need to coil up wire again and again, more wire. If by coiling up the wire again and again, by making several coils of the wire, you can increase the strength of electromagnet, right? Increasing the number of turns of the wire in the coil, increasing the current passing through the wire using a strong iron core, right? By this you can increase the strength of an electromagnet. Now NCERT also asks you the major longer questions which I've already told you, that explain the working of electric bell with the help of diagram. So this I have already taught you. You can take the notes and just write the answers as it is. Okay. You can also make the diagram. I have shown you the simplest diagram of an electric bell. You can make it in your answer. So that's it for the video. I have completed chapter number 14 of your NCERT textbook. Hope you like it. If you have any questions, just comment down below. We will meet in the next video. Bye bye. Take care.